So I'm John Wyant. I'm the faculty director of the Stanford Energy Seminar. Good afternoon and welcome to the first seminar of this quarter. So you'll hear from me during the seminars in various capacities. Next, we have Rachel Ramsden, who's in the back, who is the Precourt Institute program manager for the Energy Seminar. You'll see her around with doing all kinds of amazing logistics and coordinating different groups. As you've learned through the Canvas portal, our CA for this year is Alina Schechter, who's a joint MBA EIPER student. She's unfortunately not able to be here today, but she has communicated with you via Canvas. And fortunately for us, we have Noelle Eveland here, who's also conveniently an MBA joint EIPER student who will be standing in for her today. We don't have a sign-up sheet today because we don't take attendance, as I said before. We have a very broad range of topics this year, so the idea is to give all of you a broad range of the energy activities going on here. This seminar is sponsored, as I've said, and supported by the Precourt Institute for Energy. The director of the Precourt Institute for Energy will be here in a minute, so you'll get to meet him several times during the quarter. So it's a very broad range. There's a couple of open slots, which we are just filling even as we speak here. And it's going to be a very, very exciting quarter. So the speakers have been instructed to give a talk that's technical enough for the people who are interested in either policy or technology or whatever your systems modeling to pass muster with them, but also to be of interest to a very general audience. And some of you might be here trying to figure out what kind of energy career you would like to pursue. So just to cut things off, I'd like to, at this point, because I just did mention him, introduce Professor Will William Chu, who's the fairly new still, but running fast, director of the Precourt Institute for Energy. And with that, I'd like to introduce today's speaker, Dr. Liang Min, who's among many other jobs, the managing director of the Stanford Bits and Watts Initiative, which is in the Precourt Institute. Now, Liang is very qualified to have that job because he's done built up cutting edge smart grid programs at both the Electric Power Research Institute and Livermore National Laboratory. But, and I will say, in transitioning to Will and away from me, that our guest today is on a visit with the Bits and Watts program under Will and Liang. And this seminar itself is therefore jointly sponsored by both organizations. So if I screwed that up, Liang can tell you what I said wrong and say what's really going on. So please welcome Dr. Liang Min to introduce today's speaker. Thank you.
Thank you, John. Everybody for coming for this seminar. And we partner with Energy Seminar to have this one. This is a part of our the series of the seminars. We bring the executive CEO of a global utility energy company to Stanford to really share with us what's going on in different parts of the world for this energy transition. Today, we're extremely delighted to have the Chief Executive Officer of the French grid called RTE France. And Dr. Xavier Piechaczyk is the CEO of RTE since 2020. He became the member of Managing Board of RTE in 2015. And beyond his executive role, before joining RTE, he serves as advisor to the French president in charge of energy, environmental, transportation, housing, and urban policy, and had many different hats in the French administration for this topic, and has been driving the French energy transition for many, many years, especially in the last year was extremely, extremely interesting for the Olympic. So he will share with us what's going on in France for this critical energy transition time period. Without further ado, I will hand the mic to Xavier.
Thank you. Thanks a lot. Hi, everybody. Thanks for the introduction. First time in Stanford for me. So I'm very honored to be here. And sorry for my French English, a little bit charming. I don't know my French accent. Yes, I have a lot of slides, but not a few. Thank you, thank you. My goal is to talk about the French transition and how could I and could we manage that in France and in Europe, because all countries in Europe are this kind of situation. And saying that, maybe there is three questions you may ask, and we'll I try to enter. First, why does France, whose electricity production is already carbon free, almost carbon free, still need an energy transition? The second question is why RTE, the French TSO, transmission system operator, in charge of developing this kind of pathway to decarbonize French grid. And the third question is, assuming policymakers commit to a single desirable trajectory, which is not obvious as stable politics are needed, what does we need in terms of financial investment, supply chain and procurement strategies to avoid bottleneck inside supply chain, technological development to minimize environmental footprints, and building competencies across the electrical value chain. First, a few words concerning RTE. RTE, the French TSO, the biggest in Europe. We are responsible of the grid. We own the French grid, and we own our interconnector between the neighborhood, around 100,000 kilometers of other lines, few cable, underwood cable, around 3,000 substations in France. We own, we develop, and we maintain the grid. But we are too an operator of the grid. That means that we are responsible for operation flow management inside France and with the neighborhood. And finally, we are legally responsible of the French perspective for carbon neutrality and for the grid. If I translate that in California, we are the combination of CAISO, of PG&E and SC Edison, and we are part of the CEC, responsible for a part, for example, of flexibility on the grid. So our turnover is around 5 billion a year. Our EBITDA is around 2 billion a year, and we are 10,000 employees in France and a little part in Europe. It's for the big picture of RTE. So my first question was, why do France need an energy transition, like other countries in Europe, by the way? Because of that. On the left, you see that today, the France the French final consumption of energy is around 1,600 terawatt-hour. And you see that even if our electricity is clearly already decarbonized, France still consume a lot of fossil fuel. By fossil fuel, I mean petrol and natural gas. And of course, the main goal is to supprime this gray part by 2050. In France, there is an objective of efficiency, and the French efficiency objective is 40%, excuse me, less from today to the point of the carbon neutrality, the first goal. But we have a second goal. Second goal is to switch a lot of uses from fossil fuel to electricity. That's why we project by 2050 a biggest part of electricity in the final consumption of energy in France. So that's why I say often that for France, and it's the same thing in all European countries, decarbonization means electrification in all cases. Of course, it's a big challenge for us, even if you produce a lot of hydrogen by electrolysis or not, the same thing in all European countries. And the challenge is how to make that and how to challenge them. The point is, what could be the path, the different paths to attempt this objective of total decarbonization of the country? And maybe we could talk about the starting point in France. Probably France, not probably, surely France is a very particular country because we have already a lot of nuclear power plants. And this slide, just to represent the French mix today, that you see the yellow is very dominant. Why? Because the yellow is the nuclear French, look, the nuclear French installation. But we have a program to develop renewables too. And what we study is the manner to transform this generation mix to attempt the goal of increasing electricity in the mix because of the phase out of the fossil fuel. And we studied 6 different scenarios. You could compare with California, for example. The 3 scenarios of the left are scenario without new nuclear. That means that they are tending towards full renewables mix in 2050 or in 2060. And we compare that with 3 other scenarios with new nuclear plants in France. So the first is a little part of new nuclear plants, 12%, and the other, we increase the part of new nuclear to test these different scenarios in the mix. I have to precise that because we operate already the network, the French grid. All this kind of scenario ensure the same security of supply than today. Okay, there is no simplification. There is no sum up. All these scenarios of generation we bought are able to guarantee the same security of supply of the country, of the Europe, as today. And to simulate that, we model it each hour of each year for 40 years to test the security of supply. And all these scenarios are able to guarantee the security of supply of France and of Europe. I will be quick. What is the main result? The main result is that there is a difference of cost of these different scenarios if I accept the ideological question concerning the nuclear. And here are the main results. We calculated the annualized full cost of these different scenarios in 2060 to be able to compare it and to make a kind of guidance for the French government. What does this cost for the French collectivity? And you can see that the three scenarios tending towards full renewables mix are more expensive than the three scenarios with new nuclear. Why? Not for difference of generation, because if you see the addition of the green part of the green and the yellow on the left and the green on the yellow on the right, it's approximately the same cost annually for the French collectivity. So that means that if you choose a full renewable mix, or if you choose to mix nuclear or renewable, for generation, it's approximately the same total cost for the collectivity. But there is a great difference, and the great difference is located on flexibility cost and on grid cost. Under flexibility cost, I talk about essentially storage. It's the cost of the storage. It could be the cost of gas power plants with hydrogen. It's hydroelectricity, it's interconnection. It's the first difference. It's the orange difference in this graph. The second difference is the total cost of the grid, because a mix tending toward a full renewable mix, it's more expensive concerning grid in all cases, because renewables generation are less concentrated than nuclear plants. Second lesson, there is difference, but there is no a huge difference. The difference in the total annual cost is around 10 billion a year. The red numbers are billions. The dark numbers are billion per year. So there is a difference, but the difference is not huge. It's probably enough it was enough for France to choose to project itself in a new nuclear scenarios. That's why, with this guidance, the French president chose a mix of this scenario and this scenario. But you see that the difference, at the end of the day, is not very huge. And third lesson is the question of financing. You know what is a WACC, with average cost of capital? The gray part represent different tests with different level of WACC. The minimum there is an hypothesis with a WACC at 1%. The main part, gray, is an hypothesis with a WACC at 4%. And the up part is an hypothesis with a WACC at 7%. And what is the lesson is that it's more important to organize a transition with a low WACC to avoid make the price exploded for the community, than to be focused on the type of generation. If I make the crash test, and I say that I'm able to finance my renewables with a WACC of 4%, and for technology reason, I'm able to finance my nuclear part with a WACC at 7%. There is an equality in a total cost for the collectivity. It was the main reason. That's why in France, we try to organize the transition in a regulated world to be able to manage the WACC, which is the first parameter to make this transition reasonable. I didn't represent what could be the cost of the French transition with a WACC around 10 or 12%, but it's very, very, very expensive, and I think it's not acceptable by the final consumer. It is a huge investment because we have to organize a kind of big switch between use from fossil fuel to electricity, and obviously that needs a lot of investment on generation and on grids, transmission grids and distribution grids. And this slide to show you the need of investment each year from now, 2020, to the end of the decarbonization, I hope 2050. You see that it's a real effort of investment, but it's not huge. But I think it's not the main slide is this one. In a world where there is a lot of new consumption for electricity because you phase out from fossil fuel, the base of your consumer is increasing. And each consumer is consuming more. Okay? And because electricity is a fixed cost business, the final bill for each user is lower. That's why, despite a big need of investment, the total cost per megawatt-hour doesn't increase a lot. It increases, yes, because our calculations show that it could increase from around 14%, but it's 13% in 2060. So it's not huge. It was the main result, and that's why the French Republic decided to be guided by this prospective study and to choose these two scenarios. More precisely, this one, but we don't know if we'll be able to attempt this one or this one. That was my sum up for the survey. I talked about 3 questions. The second question was is RTE, my company, leading this type of survey? Because probably we have already the legitimacy to make that. We have a huge teams with economic, with highly skilled people, engineers, doctors like you, dedicated to this time. There are around 80 to make that for the French government. But we made that because this type of scenario are all security of supply proof. Okay, so we are able to guarantee that the security of supply of France and Europe won't be changed by this kind of transformation of the mix. Maybe few words concerning the implication of this transition on the French grid, because, as I said, RTE is not only a prospective institution, but RTE owns the French grid. We are going to release our investment plan only for the transmission grid to dimension our own investment to make available the French transition. For us, the order of magnitude of our own investment is by 2040 around 100 billion euros. In dollars, it's almost the same thing. Why this cost? Because factor one, we need to create new lines for new nuclear reactors, of course. We have to create new lines to connect new renewables, because it's like in California, a very dynamic sector. Because the consumption will increasing is the direct consequence of the big switch, phase out fossil fuel and to be converted to electricity. And before the consumption and the new generation, there is a kind of backbone, high tension grid, which has to be reinforced. And when you add the connection of the generation, the new generation nuclear and renewables, the connection of new consumer, and when you have to reinforce what is between the consumer and the generation, that means we have to invest around 100 billion euro by 2040. It's huge. And the main challenge is not how to finance that, because we are able to finance that. The main challenge is the supply chain, and it will be the supply chain, I'm sure, in US too. Because the supply chain for the grid is not dimensioned at all for this kind of investment, not at all. There is already bottlenecks in the worldwide market. For example, concerning HVDC technologies, you know what is HVDC technology? High voltage direct current. It's very hard to obtain an industrial slot to manufacture a substation, for example. And the main problem is the paradox. It's not a financing problem, but a supply chain problem. Either Europe, and the question could be, okay, for United States, able to develop a supply chain to reduce bottleneck. What do we do for that to reduce bottleneck? That's why we are going to issue a grid roadmap, our investment plan. It's principally to give visibility to our supplier. We're gonna detail all our different investments to describe how many transformers we need, how many lines, how many pylons, how many equipment, to be sure that they will be able to implement plans, structure to be on time for our investment. It was our first measure. And the second measure was a reform of our procurement strategy. How to make that? It looks simple, but it was a little bit complicated. We have relaxed deadline. We are able now to organize call for tender for long term. We extend the volume of the procurement, and we guarantee turnover to our supplier to be sure that they will be able to invest in our own plans. So one long-term measure give detail of our needs by 2040, and middle-term measures through procurement rules, increasing volumes, increasing fixed parts inside contracts, and increasing the time of effects of our contract. Last measure we took, it was the standardization. Historically speaking, in Europe, each TSO, each grid manager, has his own requirements, technical requirements. And for the supply chain, it's difficult. It's very slow to adapt each time what I am manufacturing. If I manufacture a transformer for French TSO or German TSO or a Spain TSO, and we tried with my counterpart in Europe to standardize the equipment to be able to tend towards a kind of common procurement. This goal of common procurement in Europe for equipment is a manner to help suppliers to have a life more simple and to invest in new standard plans and to make the price lower because the investments are very huge. That's what we are doing, and it begins to work. Okay, we begin to standardize with my colleagues in Europe a lot of equipment, for example, cables, to be sure that the supply chain will be on time and all the TSO will be able to be on time in their own transition, because all countries in Europe have the same goals. Maybe few words to conclude. I didn't talk about digitalization. A part of these investments are dedicated to digitalization, because for us, digitalization is the best way to minimize the footprint of the grid and of the energy transition. Even if you saw that the French electrification is not a revolution concerning cost of electricity, France, as other European countries, has a problem of acceptability of this transition, and a manner to make this transition acceptable is to turn the price lower as possible. And my job is to optimize each day the French electric system. How to do that? We do that through a part of digitalization. The digitalization and the artificial intelligence allow us to optimize investment, to go more quicker, and to limit the footprint in the French soil, and to attempt a kind of French acceptability. I don't promise it will be a success because all projects are very hard to build, but my opinion is that the only way to try to make that on time. I suppose I forgot nothing of my main messages. So thank you for your attention. And if you have a question, you're welcome.
We have about 10 minutes or 5 to 10 minutes to take questions. So we'll let the student to go first. Let's go from this one, then go to you.
You shouldn't need the mic or the room that boosts the signal for people talking in the back.
You don't need the mic. We can use that.
Yeah, no, I'll just turn the system on.
Thank you so much for being here. I have a question with respect to the utilization of nuclear energy. Has there been an increased sentiment towards essentially, is it possible to adopt it as, faster than as expected or as planned, given how nuclear energy, at least on a portable basis right now, has been essentially deemed more safe compared to it was, say, years ago? And So that'll be question number one. Number two,
Yeah,
I think that's all. I don't wanna.
it's a very big question, a very complicated question. In France, there is different challenge concerning the nuclear part. The first challenge is are we able to extend the age of the existing nuclear power plants? The first issue. It's not yet an issue, but it's a challenge. The age of the French nuclear is on average around for 40, 45 years, 50 years. So theoretically speaking, excuse me, this kind of plants were designed for 60 years. So the first challenge is how to extend the age of the existing nuclear power plants. The second challenge is how many new nuclear reactors are we able to build from now to 2050. And we think that the maximum, what is the industrial max for France is to build 14 new reactors by 2050. Why? Because the new generation of nuclear reactor is not totally designed, and it's very long to build. So, and the industrial max in France is 14 new reactors of the third generation by 2050. It's the max of this scenario. And we made the hypothesis to be able to develop SMR, small modular reactors, to complete the base of old nuclear and new nuclear. And my hypothesis was around 4 gigawatts of SMR. It's a challenge too, because 4 gigawatts of SMR is huge. So that's why how most nuclearized scenario combine there's 3 challenges: how to extend existing nuclear, how to develop a very quickly third generation of nuclear, which is not totally designed yet, and how to build very quickly small modular reactor, which are not totally designed yet too, to be honest. But it's the same thing in US for civil uses. Okay? It's a combination of the 3 challenges, but the industrial capacity of France and Europe to build was an input. That's why this kind of scenario are not theoretical. They were built after a great consultation with all stakeholders to fix what is the maximum capacity of France to build concerning nuclear, but concerning renewables too, because we dimension the part of solar and the part of onshore wind and a part of offshore wind. Is it clear?
Very clear. Thank you.
You're welcome.
I think we can take one more question. Maybe 2 more questions. Good.
Madam? Yeah? You
Yes, I had the same question about SMR. I was trying to figure out what you meant by nuclear and to what degree it incorporated the new SMR technology.
Yeah.
Same thing.
It was a small family with existing nuclear in yellow and new nuclear for 8 new reactors in France by 2050. The second scenario was the same, but with 14 new reactors. And there we artificially extend the age of installed nuclear of second generation, and we add small modular reactors to try to test a very nuclearized mix. You're welcome.
Yes. Question on how the Russian invasion of Ukraine and the natural gas cutoff there impacted like your planning here, and if it did at all. And then second question might be kind of basic, but how connected are the grids within Europe? Because I just did a trip in Germany and they were talking about how they're kind of building up their ability to have a hydrogen economy, which is like totally different strategy to what France is doing while Germany's shutting down their nuclear plants. So like, how much can you guys help one another out in this?
Okay. The war in Ukraine didn't impact our strategy. It reinforced it. Why? Because before the war, the strategy of France was to quit quickly fossil fuels, including gas from Russia. But you're right. This plan was, before the war, only a political commitment. And now, because of the war, it became a kind of emergency. And the question of sovereignty became very important with the war. And it's particular because the French society moved about this question. The mix, the different mix like that, even if you choose full renewable mix or nuclear mix, are probably more legitimate in the Ukraine war than before, because it became a question of sovereignty. Why? Because in this case of production, the main energy you consume is produced on your own soil. So it became naturally a question of sovereignty. You're right, it changed things concerning electricity or gas prices. Okay, but it's for a short period. In the long term, the tendency was to legitimate the strategy of electrification. It's not a total electrification, but it's a majority electrification. And the second question was, how do we manage the different approach, the different approach between, for example, France and Germany? It's a difficult question. It's the same problem than in United States to coordinate different policies between states. But we are more integrated, I think, in Europe than here, because we are all driven by common objective concerning renewables, concerning emissions, concerning decarbonization, and now concerning electrification of our industries. So we have common milestones, we have common bearing points to be aligned. You're right, there is difference of rhythm concerning renewables development. Germany is higher than France, Spain is higher than France. Then there is often during summer big importation from Spain and Germany toward France because of the cost of the solar, for example. But for the moment, it's manageable, and we manage that through our common interconnection. And the company who is in charge of the management of this interconnection is RTE. So it's a manner to schedule the rhythm in a long term of exportation and importation. So it's never a miracle. Okay, there is always tension between countries, like in US, between different states. But I think that our common milestone could be able to be aligned, even if there is small incident or accident.
I think you have one comment, your colleague. Go ahead.
One compliment about this change.
It's my French colleague, so it's not a question for me. Yeah.
For you, but just to complete the view on the effects of the war, the Russian invasion, full invasion in Ukraine on the scenarios, it doesn't affect the scenarios themselves, but there's a strong question about the supply chain, industrial supply chains, investment and so on, coming from the geopolitical context, the commercial conditions. And FCO is working a lot on that also.
What was the consequence of the war is that Ukraine was disconnected of the Russian grid, and European people and European countries connected Ukraine to our grid for frequency, and it's very important to guarantee the security of supply. So it was a technical consequence. The first, we made that in February 2023. And electrically speaking, a second consequence of the Ukraine war will the 9th of February, of next February, to disconnect Baltic countries from Russian grid and to connect Baltic country to the European grid, because it was bizarre, but Baltic country, even if they are member of the European Union, were still connected to the Russian grid. And from the next February, Baltic countries will be connected to the European grid to be in a kind of security world.
Very good. With that, let's give another round of applause to Dr. Xavier. Thank you very much.